Welcome to the next segment of X-ray virtual training. We're going to start talking about some of the software and the instrument itself. So when you first walk into the lab, you are going to see the instrument. It looks something like this over here. And there's two things you should really check before you do anything. Number one, at the very top, there's this X-rays on light. So the X-rays never get turned off. They should always be on. We turn the X-ray power down at the end of the day, but they should always be on. And so you should double check that this light is on. The next thing is that you should take a look at this light here on the front panel. I've blown it up down here at the bottom. It should be on and solid green. There should be no flashing. And so just take a quick look at those two things when you walk into the lab. If either of these things are not the case, let me know and I will help figure out what the problem is. So I want to give you a brief introduction to the software and the different sections of the software that we use to run the instrument. First of all, the icon down here, the little globe, is the software that we use to run the instrument. That software is called Smart Lab Guidance, partially because it's going to try to guide you through the experiment. So there are a couple different sections of the software. The center section is where you're going to see your data. This section up here in the upper left is where you're going to see any current conditions. So for various angles, theta to theta, omega, things like that, you will see those angles recorded here. You're also going to see the tube voltage and tube current, which are going to be very important to our training in just a minute. And so this is where you find all of those current statuses. On the upper right-hand corner, we have a number of different experimental packages. These are essentially experiments that can be run. The most common ones are in this general measurement section, and we'll talk about some of those in a little bit more detail in a minute. I will point out that there are a couple tabs here, and you are going to be running packages in this pre-installed tab. I will also point out that there are many packages, so you can use the slider to go up and down and find where you want to be, but typically you're going to want to be in this general measurement section. And then down here in the lower left, when you double click on a package, that package will appear down here. The steps of the package will appear down here. And that's where you're going to actually execute them from. So the first thing you're going to do within the software is you are going to double check the tube voltage and current. The system can either be in standby or fully on. When it's in standby, the tube voltage will be 20 kilovolts and the tube current will be 2 milliamps. When it's fully on, the voltage will be 40 kilovolts and the current 44 milliamps. So in this case, the X-rays are already on and we could skip the next step. But if you came in and you saw 20 kilovolts and 2 milliamps, you're going to have to slowly turn the X-ray power up. And I'll show you how to do that next. So within the software, there's a control tab at the top. You click on that and select aging. That brings up this window that you see in the bottom right. You're going to double check that the program to run is called Use Every Day. And that defines the parameters down here in this table. What this table is telling us is that it's going to start at 20 kilovolts and 2 milliamps, and it's going to hold for 1 minute. It's then going to go to 20 kilovolts and 5 milliamps and hold that for 1 minute. And so on until it gets up to that maximum power of 40 kilovolts and 44 milliamps. Once you double check that this says use every day, you can hit the execute button and it will start ramping up those voltages and currents. The aging process takes about 15 minutes, so you should plan for this in your experiment. Once the X-rays are on, you can choose a program or a package that you want to run. And we discussed a little bit about the different packages or the different instrument geometries and what they are good for. To briefly review, the Bragg-Brentano geometry is best for pretty flat samples. And so that could be powders, or it could be thin films that are relatively thick, greater than a micron. The PB geometry, or parallel beam geometry, is best for rough samples or thinner films. And this PB-PSA is what we use when we want to do a grazing incident angle experiment, especially for thin films where we don't want to penetrate too much into the substrate. And so again, these are all located under this general measurement folder. When you double click on the one that you want to run, then it will be put into the program portion of the software. And so you can see we selected the Bragg-Brentano geometry, and we have an optics alignment, a sample alignment, and a general measurement. And these are the three common parts of the experiment that we always run. And so let's walk through all three of these. To get started, we're going to start with an optics alignment. The particular optics alignment I have is a PB alignment that's set up here, but they both, the software looks the same when you run each of them. So the two things that I take a quick glance at before I hit the execute button are just what is the current attribute and what is the destination attribute. The current attribute is how the system is currently aligned, and the destination is how it's going to be aligned once this optics alignment is complete. When the alignment is finished, these two should match each other. In this particular case, they should both say medium resolution parallel beam. If they don't, then something probably went wrong with the alignment, and you should let me know. And I'll help you figure out what happened. So again, I take a quick look at these, and then I press the execute button. One of the nice things about our software is that it tries to guide you through the experiment. So you've said, I want to do an optics alignment PB, and it's then going to tell you what you need to put in the system in order to do that alignment. And so the software and the hardware, the system can read what optical components are in place on the system, and it knows what experiment you're trying to do. So it will recommend for you to insert or remove various optical components in order to do that experiment. So you don't have to know exactly what you need, you just have to know what kind of experiment you want to do, and the software will walk you through it. I do need to point out that there are two components, this height reference sample plate and the center slit. Those both go right in the center of the instrument. The software cannot read those two components, so it will always tell you to put them in or take them out, even if they are already inserted or already removed. So it's just a little friendly reminder that it can't read those, and it's just double checking that you have them in the correct position. And so the next thing that you're going to have to do is you're going to have to follow those instructions and actually open up the chamber and start to put in the correct optical components. To open the X-ray diffraction chamber, you're going to push this button here. I've got it blown up down in the bottom. It's the door lock button. So when you push that button, the system will have one long beep, and then that will be followed by shorter beeps. They are pretty annoying. You're just going to have to get used to them. But once you start hearing the shorter beeps, then you can use this handle to push the door to the right and open up that chamber so that you can see inside. When you are done changing out the optical components, you're going to close the door and then push the button again, this door lock button, in order to get the system to stop beeping. And then you can go back to the software and tell it you have finished those changes, and it will proceed. That's the end of this section of training. Your next section is going to look at a little tour inside the X-ray diffraction instrument.